And we're on air. Hey everybody, so we're here for another episode of Cutting Code. It's me and Rob again, and we're continuing the diversions from our previous CSS hacking to do something a little bit random, and we're going to build some pathfinding for video games today. So this is a bit of a novelty. It's not something that we do. We don't build video games for a living. Luckily for us, though, there's a really well-trodden and popular algorithm called A star. So the A star algorithm is a variant on Dijkstra's algorithm for pathfinding. Hey everybody, so we're here for another episode of Cutting Code. Oh, that's an echo. It's me and Rob again.
Oh, is that me?
The diversions from
Is that me?
No, that's because the YouTube channel was opening another tab.
Okay, cool.
We are really live there. There's always something, right? Lol. So the A-star pathfinding algorithm is fairly popular. It's in a lot of game engines built in, I think. We don't build video games, but it's a fun puzzle. So what you can see in front of me here is a little code kata that we put together. So the A-star search algorithm is a pathfinding algorithm with many uses, including artificial intelligence for games. The search builds a route from tile to tile until it reaches the goal. And to help choose the best possible tile, the algorithm will use an equation that takes into account the distance from the tile to the goal at the cost of moving to that tile. So we've built this little fake game world here. I'm going to make that a little bit bigger so everybody can see on the stream. This is a very, very trivial, simple text representation of a game world, with the S down here being the starting point for your character, with these hashes representing immovable, unpassable objects, and the V's representing a forest. So the idea is that the dots here are planes that can be easily traversed. You can't walk through walls, and the forests take a lot longer to get through. So when you're building pathfinding algorithms, you're going to want to, for instance, path around the hard-to-access terrain to get to the D, the destination here, much quicker. So we've kind of taken this problem here and we've broken it down to a few small steps. So in fact, I'll stay zoomed in. Why not? So I've built up these user stories. So as a pathfinding AI, given a 3x3 block, I will pathfind diagonally. So this is just to exercise the fact that the A-star algorithm allows you to pathfind both left and right and diagonally. So there's probably a couple of tests we'll end up writing that do the left and rights before we get to it. But we want to prove that we will take the shortest route. We've got a story around pathfinding around a blockade. So as a pathfinding AI, given a 3x3 block with a blockade, I will pathfind around it. So as you can see here, the starting point here, S, has some clear travel around here. So basically, we want to check that our algorithm that we build can walk around this wall. And pathfinding around a slow terrain. So as a pathfinding AI, given a 3x3 block where the direct route is slow, I will pathfind around the slow block. So the idea here is the V has a difficulty of 5, and the dots here have a difficulty of 1. So we'd expect our path to walk around the forest. So we're going to build something that spits all this stuff out into the console. We've got some exceptions criteria here that we should path output to the console and mark the path that we've taken with crosses on the screen. So nice and simple, or at least so it says, so it looks. And luckily, because the algorithm is so well documented, we kind of have the thing that we're meant to build laid out here. So the idea is you search the surrounding tiles for walkable choices, and you work your way through the list, calculating the cost of movement from the tiles that you start at till the tiles that you're going to end at. You then choose the next most obvious path and continue walking. So what we're going to do, I suppose, is we're going to start by building some test cases up, and we'll see where we get to. So I'm going to switch back to Visual Studio here, and I guess we're going to probably need that first test case.
Yeah.
So let's just
I think it's be interesting because, like you said, this is so different to what we do day to day. I think it's going to be very interesting.
So let's say a diag path is something like this. And that's going to be an incredibly annoying string. / So let's at least. Oh god, that's horrible, isn't it?
That is pretty horrible.
Horrible. Visually represent. Okay, so let's do this. Trim start. That kind of works.
Oh, that's gross.
It is really super. You got any clever ideas?
Well, oh, that's gross.
We'll go with it.
Like, yeah, the only other thing I would probably suggest would be to put it in an array or something. But yeah,
I kind of like.
yeah, simplest thing. Like, let's just go with this, and then we get fed up with it at some point.
So should we do the simplest possible thing at all here? This very, very first test, which is probably path, one row can walk left. You know, something really, really super, super trite.
Yeah.
So call it world equals s dot d var path something path walked equals Pathfinder walk world. Horrible. Really, really horrible. We'll go with it. And who cares? Static all the things. Who cares? And we want to assert that the output probably looks something like probably XXX or SXD. Something like that.
Yeah, I'm already just like, holy crap, there's so many concerns here. Like, is this, sorry, one other thing, is this right or left?
It's right, it's not left. Definitely can walk right. Oh. But it's okay.
I'm also thinking, like, the path walked, is that going to come out like this? And then, oh, sorry, yeah, this is the world here. Sorry, I got distracted by that.
Yeah.
Okay, cool. Okay.
We could just make that one pass, right?
Yeah, let's just do, should this be a string?
Yeah, that's first principles. To everybody watching, if you've got any questions, we've turned the Google Hangouts questions thing on. I'll try and pay attention. Okay, cool. So what's next? Maybe come walk downwards?
Maybe we should go left now. Like,
yeah, why not? Why not go left?
I want to learn to type. Oh, it's damn cough.
Cool. And annoyingly, we should probably break and take a look at the algorithm at this point. Because
no, man, just hack. Just hack.
Okay, we can brute force.
Move fast and break everything.
Okay, fine.
No, I'm kidding. Like, let's have a look. Like...
Troll. Okay, so the computer scientists of yore say that we should search the surrounding tiles for walkable choices. We should then go through the list finding the cost of movement for each of those choice tiles. Let's forget about the cost of movement. Who cares about that stuff right now?
Yeah.
So we're going to look at all our surrounding tiles and we're going to work out a distance. And then we're going to do something to do with the distance and we're going to start walking.
So I think if we just focus on step one for now, like get comfortable with that, then...
Yeah, let's do it.
Yeah.
So let's just use a string. Let's just use a string. I mean, what we probably want to do is say something like WorldMap equals world split on new... I really, really wish they would fix this syntax. New list of string, environment, new line, string split options, none. I mean, come on. That is just the worst API to split something on. Horrible. But we'll do. We'll take it. So we've got a map. So it says scan the surrounding tiles. So I suppose what we need to do is we need to find the starting point and the destination point.
Yep.
That makes sense. So start point is
I think there's actually a type, like a struct for point, isn't there?
yeah. So I guess there's probably not even a clever way to do this, is there?
Um,
Just two loops. Always two loops. Why is everything two loops? And this is where we always get it backwards. So we're going through each line. So this is each y. This is each x. And then we're gonna. No, these are the.
yeah, that's the Y, because it's going to be
This is the y.
split on a new line.
And this will be a string, yeah. So for each char position in y, and we'll call this something like x position. X position.
Let's do it as X.
And actually, let's probably do something like this, because it actually seems to make more sense. So this is a cell, and to be honest, can we stack these? No. Okay, so we've got a cell which is, yeah, this is X. This magic eye is actually X, and this is the single line. So we're scanning across, and we're saying if cell is equal to S, and yeah, there is a point.
Sorry, this is naming right. It says WorldMap.
Yeah, this is our grid.
So this would be the line, not the Y coordinate, right? Or am I missing something?
Yeah, so this is row.
Yeah.
You're absolutely right.
And then this is going to be.
X is Y, isn't it? It's just resharper.
Yeah. Is that right? Yeah. God, I hate coordinates.
System drawing point, we probably don't want to use that.
Yeah. No, I thought that was just a struct already, but screw that.
No. So if it's S, we found the starting point. Let's just do it cheap. Start X equals -1 bar start Y equals -1. And this is nasty, but we'll go for it. Start Y equals Y. Start X equals X. So this is totally a function, but we'll refactor that out soon.
Yeah.
And I think I do want a point class of some description here, because that's just horrible. And X and Y. And let's just put some. Let's do that. Okay, so point start equals, well, nothing. Start equals new point X, Y. Okay, so we've got the start point, and we need the end point. And this is very, very much a method, so I'm just going to extract it. Find thing. Oh, that's blatantly not really what I wanted, but we'll go with it. Find thing, and we want to return that.
I was wondering if it might be easier to actually pass in what we were looking for.
Yeah, totally where I'm going.
Okay. Backseat driving, I'll shut up.
So I'm searching for this. If cell is that, return that. And at the end, return null. So I'm searching for S. So now I can do var start equals find thing S and var dest equals find thing WorldMap D.
Then I think we can then just say if start is to the right, then return step left. Do you know what I mean?
Yeah.
Like hack that bit, you know.
Yeah. And that is the simplest thing at this point, isn't it?
That's what I'm thinking, yeah.
So if start x, ooh, just alt tab somewhere. If start x is less than dest x, return. So if it's to the left of it.
Yeah, so you want to step to the right, then yeah, otherwise the other way around. So let's just change this one to be DXS.
Haha. No. Okay, cool. So that's definitely the A star algorithm, but it's a thing that works.
Yeah, it's something.
It's certainly something. Okay, so
Up down.
up down path 3 by 3 can traverse. We'll go with it vertically, and that's a terrible name. We'll change
Like we've gone from beautiful. Like why not just like path 2 rows can walk up? Is it up or north? Ooh.
It needs to be 3.
Is it?
Yeah, because otherwise they're just next to each other.
Yeah, but what I mean is we don't have vertical stuff yet.
Okay, so 3 by 3. So yeah, instead of being 3 by 3, 3 grid squares vertically. I know.
These sessions are the best just to see the names. Like
The poorest names in the entire world.
Like, you had one row. Like
I know.
Like, have like one column.
Okay.
Like,
Okay, you win. One column can path up. There we go.
okay, executive decision. Like.
Can walk up. Executive. World is okay. Now we're going to steal this ugly as sin syntax, and I apologize to the gods of formatting. Vertical world, the world of tomorrow. Start.
Oh, damn, that's nasty.
And let's go with can walk down, because then I'd have to change less things.
Fair.
Path walked equals Pathfinder. Walk. Vertical world. Assert that path walked is equal to ugly path walked. Which is basically lowercase x. Expected path. There we go.
Oh, that's nasty. Okay, cool. Right. So we're doing that walking down. Okay, yep.
So that is totally an extension method on a string array.
Yeah, that's what I'm thinking.
Totally an extension method.
Okay, so in this case, I just want to look at the y. So, is that going to screw over the other ones? I don't think so. Okay, start dot y is rest. Well, if I do the return, no, I can't do that. Now, the other two test cases, they're going to have y of 0, aren't they? They're going to be.
Yeah.
Yeah, they're going to be the same. All right, so. Right. We want to. No, this not gonna be right, is it?
No. And I think at this point we actually have to do what the algorithm tells us to do, rather than being obstinate children and pretending that computer science didn't exist.
Okay, what was it again? Oh, this is me. It's wrong tab. Sorry.
That's totally my start screen.
Yeah, I might have broken you now. Sorry.
No, I'm back. It's fine.
What was it? What were we supposed to do here again? This is the, yeah.
Here we go. So we've got to search the surrounding tiles for walkable choices. So at that point, we have to find all the neighbours.
Yeah.
We have to find all the neighbours, and I suppose the first thing we do is we get all the neighbours, and then we take out anything that isn't walkable.
Okay, so I'm thinking this is gonna. We need more than this now, right? Like I think this is we've just been like we're traversing the whole map every time. You know, that's gonna cause us pain now. We essentially just want give me a grid, right?
Yep.
And then
so we already have a grid. The world map is a grid. You can address it like one, so you can do things like.
Pathfinding.
Goddamn narrator.
The narrator. So obviously, because a string array, you can do things like.
Oh yeah, of course, yeah.
Right. So we have a map.
Okay, so this thing is actually still good, but we want to find the surrounding ones. It's only the first immediate ones, isn't it?
Yeah. So we basically have a position that we start moving around the map.
Yeah.
So from the start, we're starting at our start position. So we're saying get all the neighbours from start.
Okay, cool. Let's just do that. So neighbours. Now, if I do the world map. Oh,
So the neighbours will be a list of points, won't it?
Yeah. Oh. Do we want to? Is it just be the one, or just like, well, just do neighbors, I guess.
Yeah.
Cool. We need an extension method. What are we? An array.
I don't think you can put your static class here because I think this.
Oh, my on the scope. Yeah.
Yeah, we need to take this and just go boop, down to here.
Thanks.
Push.
So we're expecting a list of points back.
Yep.
It needs to be static, Rob. We're going to base this on our.
So close.
Oh, where are all these things coming from? I've got them all. Sorry.
You've not got a method name, so resharper is.
Yeah, I can't write code, honest. Okay, so we're going to get given a start point. That would make sense.
At this point, do you think it's worth us breaking out into some tests around this extension?
Yes. Well, yes. Just because it's going to make our life a lot easier.
It really is. So let's comment out this thing that blatantly isn't building up here. Oh, actually, it was building.
This is bit that's not building.
Yeah, so if we just we'll drop in, yeah. There you go, you're on.
Thank you. Empty. What do we want to do with empties and shit?
Yeah, easy. We can crack this
yeah.
String P.
Yeah. We just need a point. Like that would be really good.
That would be really good. You're right. So, yeah, cool.
So we get the point of that, and then we should assert it's n unit. Sorry, I've been in mspec world for a while. Is it empty? Does that work for a collection? Yeah, it
So
does.
that result is empty.
Is that for that works on the collection and everything? Yeah.
Yeah, it'll work on the collection.
All right, cool. And then for numer. What am I doing? Point.
And obviously the method signature is off.
What the fuck?
Oh, it's new resharper.
Being really obnoxious. Cool. Oh, where am I? Sorry. No.
It just needs that.
Oh, okay. Oh, is that what it's doing? It's saying, oh, you need to change this thing. Okay. Cool.
Okay.
So I got our empty. What's next? What, do you want to do the next? Are we still pointing this, or do you want me to smash out the whole thing? Like,
Yeah, why don't you just write it?
yeah, just write the whole thing.
Empty array. Again, like null returns empty. Null array. So let's keep it consistent. Actually, null array. Yeah, let's do that.
Yeah, with things like this, I'm like, people are gonna. The natural thing is people are gonna want a for each. If you're doing numeral empty, it's not really expensive.
This is one of those crazy side effects of extension methods, isn't it? Because I can do this.
Yeah.
Array equals null, and people are always amazed how that actually works.
Yeah.
Which is utterly bizarre.
What? That they're amazed?
Well, obviously it looks like it will throw, because the way extension methods work, you can extend a null instance of a type declaration. So I can say, here is a string array that is null, and then I can call the extension method on that null.
Yeah, but you're not extending the instance, you're extending the class, right?
Exactly. Interestingly, it's exactly how ASP.NET Mini Profiler works. They extend something that could possibly be null. I was quite surprised the first time I saw that actually worked. But okay, so now to the good stuff. Neighbors. So what's the best thing to do? Okay, given single item returns empty again. So string array of new that with just a string, and that should return again empty. So that's just going to pass. Where's our first test that doesn't? And in fact, let's not use spaces. Given single row returns neighbor. So if I have 1, 2.
Well, the point is supposed to be the start point, right? So yeah, 0, 0 is going to be what you've got as position 1 here. So it should return.
Yeah. So result first should be equal to 2 there. Make that pass.
Cool. Cool. Oh, my keyboard. We need to cover the. I'll get out fast. Like I probably what the. A bit more. I've totally forgot. My brain is imploding. I probably don't need to do that for for each in, but I prefer to be safe. Okay, so I'm just gonna be lazy.
You're just going to return 2.
Yeah, well, I feel bad doing it.
And you got to put it in an enumerable.
New
New list of points.
list? Yeah. That's not a point, is it?
My test is totally wrong, isn't it?
Yeah, so we get the list of points because I think the grid, in terms of finding the neighbors, is probably going to be very different to assessing what the neighbors are. Like, is it a forest? Is it a cliff? So, is that what we want? Like,
It's a good question.
because the points are going to be important, right?
Yeah, I think we do want the points, actually, rather than the thing that's in them.
Okay, so let's do. Is equal to going to work okay on this? I don't know what kind of comparison it does. So we're saying it should be x. Sorry, 1,
Yeah.
0. And then if I do point here, and then 1, 0. I don't know what kind of comparison that's going to do.
Now we'll probably have to override equality.
Yeah. Or we could maybe just convert point to a struct.
Sure.
Maybe get it for free.
Oh, don't be annoying. Are we going to get that for free?
I thought we would get that for free. That sucks.
Feel like, yeah, building isn't working. Let me actually do a real build rather than Crunch just magically building for us.
Oh, this is the thing.
See. Let's not just... Whenever I think, oh, let's just make that a struct. But thankfully, Resharper will give us it, I believe. I believe there's a magic implement equal.
Isn't it? Yeah, I think it's is it God, what is it? You can just do EQL as a snippet, I think, isn't it? Or like equal, yeah.
That. No, I'm sure it generates maybe it's when you do a get hash code. I know there's definitely a resharper, please give me a hash code. I mean, I could just do it by hand, but...
Yeah, like for the sake of two properties,
Hash code? Public override get hash code. I always thought it was one of Resharper's quick fixes here. It's alright, we'll just...
I always did the equals thing and then just said fine and then did it. Because you need to override equals and hash code, right?
Yeah, you do that and then it complains. Normally when you override one of them, it complains about the other. Generate equality members. I don't know where they've moved all this stuff to. There you go. Equals, point, other, get hash code. It's just because of that. Probably.
I love the comment of override object equals above the method called public override.
Is that not it? I'm just hacking at code here without actually thinking. So it's public override bool equals object obj. Because what they've done is they've made this a point here. I'm sure this functionality has changed in subsequent versions of Resharper. So what they've got here is that should... So we override equals there and we call equals here with a point. And that should go to here. And there we go, we've got our equality members. I mean, I'm not going to read any of that, I know it's right. But your test passes.
Yay!
So that definitely, Resharper's magic definitely did work.
So I got an issue up here with the so this has no neighbors, and that's because over here we're doing this. So
I'm not quite following. Oh, so that are some.
Yeah, there's one. So if we basically say, I think you could cheat.
Yeah, sure.
Or not.
That's weird.
No, we only got one row here. What we need is we want to see if it's only got one row with one.
This is a bit of a nasty hack.
Yeah, I'm not liking it. Do not want.
So let's do it properly. Let's fix the test properly.
The test or the code? Yeah.
Well, I mean, you fix the code to fix the test in this case.
Okay, so we need to go through our map. We basically want.
So whenever I've done this before, I've always brute forced it.
What do you mean by brute forced it? Like.
Well, we're given a point, right?
Mm-hmm.
So given a point, there are what 1, 2, 3, 4, 5, 6, 7, 8 neighbors. Like I know that for a fact. So just do this for the time being. 2, 3, 4, 5, 6, 7, 8. This is crappy as hell, but so there are 8 possible neighbors, and it's point.x minus 1 point.y. So that's the first one. And actually, let's just do it this way. And then there's x and y minus 1.
So how is this like? Are we going top left to bottom right around the point?
Yeah, let's do that.
So that's going to be. So we want y. So x minus 1, and we want y plus 1. That'll be top left, right?
Yeah. Yeah, 1 back and 1 up is.
Then we got say above.
Yeah. Yeah, you got it.
And then above right.
Yeah.
Where are we at now? So 4 is going to be 1 behind, same level. Then 1 in front, or to the right, I don't know, whatever.
Yep.
Same level. 1.
And then 1 below.
This is supposed to be plus, right?
Yeah.
No.
No, minus is fine.
Yeah, but that's. Yeah, but we're not doing. I'm in graphics mode. I'm doing.
We're thinking about y's here.
Yeah.
Plus, plus, plus. So we're 1 row above. So y is 1 row above on the left, in the middle, and to the right.
Yeah.
We've got this row, which only has 2 members.
Yep.
So to the left and to the right. And then y minus 1. So we've got 3 on the y minus 1.
Oh yeah, of course, yeah.
And similarly, we've got 1 behind, just 1 at x, and 1 there. Those are all the possible.
Yeah, so those are the points of the neighbours. Some of these will be minor, some whatnot.
Curious why the tests are blowing on this here. On this first line. Let me click that. Object reference. Are we passing in a null at some point? Okay, let's find out. I'm just deadly curious as to how.
Yeah.
So point x. I mean, seriously. That's totally okay. That's what I expected to happen. I think it was just being weird.
But I'm concerned that it's being so weird.
Yeah, kick and crunch and make it recycle everything. We've got a question that says, can we move diagonally? Yes, you can. Yes, you can move diagonally. Okay, so what I've normally done before, and it's the scuzziest thing on earth, is I just try to get those points from the grid in a try-catch.
Yeah. I'm still really concerned about this, because what the hell? Like, why is this here?
Hey, look here. Oh, I know why. It's because I haphazardly chucked a null in here during a refactor. That's why.
Okay, so let's. Well, I'm common to. I think it's fine to do that. Is the class? It could be null. Where is an instance? And then.
Oh, okay, cool. So I'll put that back in.
Yeah. But I think that's totally valid. It is a class. It could be null.
Yeah. Okay, cool. So it's not blowing there now. So those are all the possible points, and actually, the clever way to do it. Possible points equals new list point, not list point, list of points. We'll take that there. God no, that's not.
Yikes.
That's what I meant. Ish. Just do that. So those are all the possible points, and then for each var point, impossible points. For each p impossible points, we say world. What's it called?
Map.
Point px. No, it's py, isn't it?
Yes.
Py px.
Which now I look at that, I think, oh, that's misleading.
Yeah, I know. Points that exist equals new list. Again, this is nasty code, but I'm just going to hack it for now in the interest of getting us through here.
So this is going to throw an exception, right?
Yeah, it totally is, and I'm just going to wrap it in a try catch. Told you it was nasty.
Lols.
Right. Char. Okay, cool. So var point that exists equals that, and then we add p. Yeah, because it'll throw. But I mean, that's super terrible code.
Just curious why we're failing.
Good question. Huh. What? Really? Let's debug through this. Break into the first failing cover and test at this line. Okay, so we've got a map which has one thing in it, and we're asking for that exact thing for each possible point. So we're looking for, let's just check this, -1, 1, 0, 1. Hopefully we're not looking for 0, 0 anymore.
Yeah, I mean, I don't see how 0, 0 can be in there.
Those are all the neighbours.
Wait, we're not. Are we returning this?
Oh, super lol. Go green. Thank you.
Okay, cool.
Thank you for my greens. So then the only thing that is failing up here is the thing that we know is failing all the way back. Oh. Ho ho ho. So these were passing before, weren't they?
Yeah, can we just go back to that method, because there's probably
You drive.
let's have a look. So what we're getting here. Four. Wait, the vocals weren't passing.
No,
So that one wasn't. Yeah, that one wasn't passing.
This one was.
Is that because we've got a typo in here? I don't recall this being here.
Yeah, I think so. We probably pushed the keyboard on the way through.
Yeah.
So now I would expect this to go green. Yeah, so the verticals are failing there, but that's passing. Yeah, it's nothing more than typo. Nothing more than typo.
Cool. I was like, say what? Okay, cool. So now we know. So we know these points that come back are valid neighbors.
Correct. We have to get a valid point that we're looking for here.
Yeah. So how are we going to work this? So We know what ones are neighbors. Therefore, sorry, I'm just thinking this through. It's been a long day.
So let's go for the first thing. We're going to put the start in there. Get me the neighbors of the start. Let's jump back to the algorithm and just check what we're actually meant to be doing. So search the surrounding tiles for walkable choices. Go through that list, finding the cost of movement for each of those choice tiles. The cost of movement is the path cost so far, plus the cost to move to the tile being considered.
I think what worries me about this is like we've been a long time since we've been green, and like we're still kind of. I'm worried that we're going to run off onto step 2 before we actually get back to a working step 1, because we kind of had that working for the simplest cases.
Yep.
And we've not covered diagonals and stuff either. So, and I think if we have that, like, then that's a good step forward. Do you know what I mean? Just feels like it's been a long time since we've been green.
Yeah, I agree. Let me switch you back here.
Okay, so given all these points, that's just going to come back as a list.
So we want to actually get those values, don't we?
Yes. What I'm thinking is there some. What's the easiest way of doing this? I don't know what I'm thinking, to be honest.
Okay, so the simplest thing that we're doing now is we're gonna grab from the world map. So for each valid neighbor.
I'm not sure, like, because like what I'm thinking is if I have a string, right?
Yep.
And then I go through each of my neighbors.
Yep.
And then just like update the string accordingly. Like so for example, like we got this. I know I'm going to have an S, but I know that the ones that oh shit wait. So the start point.
Yep.
If I compare the possible that's come, the neighbor that's come back.
Yep.
I know that if it's +1 on, well, if the y is greater, then it's got to go above, and so on. So it's kind of like if we then just change the string as appropriate.
Yep.
I don't know. Yeah, what do you think? So what I'm thinking is that ultimately, if I just like do this, we're basically going to end up with. I know there's an S somewhere, but there'll be a grid like. We're not sure what these values will be, but like these will be points.
Yep.
So my S is going to say my S is here in our example. I then know that if the neighbor that comes back is x plus 1,
yep.
then x. Do you know what I mean?
Yeah.
Does that make sense? Like, and I'm thinking if we just build the string up based on that.
I think the idea of the algorithm is we go through all the neighbors and we assign them scores. We assign them difficulties.
Yeah.
So we look at the contents in the map. So let me sketch something. So I've got an option, and this is a point for each point, and then I can kind of say in score. Let's do this equals 0. Starts out as 0. For tile type, let's just go with it. World map. Point, and again it's confusingly backwards, y, x. So that's the character. So if tile type equals dot, then score equals 5, and that's what the
0, 1.
1.
5's the forest, isn't it?
So it's a 1.
Is it 1?
Yeah.
Yeah. Okay.
Else if tile type equals v, score equals 5. Flat ground, forest, and there's the hash. Else if tile type equals hash, and this is actually unpassable. So we need to remove before we go in. So neighbors. Actually, let's forget about that yet. We don't have that yet. I don't care about it. Let's convert that to a switch. Fine, there's a score. Let's go get difficulty of passing this tile. Terrible name, but we'll come back to it. And return that. And return that. Cool, something like that. Score equals that. So there's the difficulty for that tile type. And back to the doc, it says the cost of movement is the path cost so far plus the cost to move the tile being considered. So we've got a token that's moving forwards as we go, basically. So we're walking this map. So this is actually secretly in a loop. So it's kind of a loop here. So like var equals start, something like that actually. And it's almost like while current does not equal. Well, let's not do that right now.
Like I guess like we're like adding so much stuff, and it just feels like it's been ages since I've seen a green light, and like I'm really like I'm trying to account for the fact that my brain is imploding. Like it's been a long day, and I know I'm gonna screw things up, and I'm like thinking slow. So like I'm thinking, like.
Okay, so I can make the test go green.
Okay.
So first, I'm just gonna do this. I will cheat like there is no tomorrow. Okay, so if start y, it's exactly how we were going to do it before. Dest y. Well, oh god, that was a page down. So if start y is less than dest y, return sxd, and I'm going to be really horrible here.
Nice.
And it's probably the other way around, isn't it?
Yeah, so if the y is less than the does it need to be environment new line?
That's a carriage return new line. I'm just wondering if we are expected sxd, but what was dxs? Really?
Let's have a look at the code again. So start y is.
So if we start higher than.
Oh, it should be less. I think. Yeah. So start y is less.
Is less than destination y. Very, very simple. Feels like it's not building. That's why. Whatever.
Nice.
There you go. There's your green.
All right. Cool. So, like, I'm thinking it's refactor time because I think there's a few things that are confusing us. Like our map is like back to front.
Yeah, can we get this finder thing out into a static extension class because it doesn't really need to be in here.
Well, so do we want to have something that actually gives us a grid first? Like, what do you think?
Well, we have a grid, don't we?
But it's all back to front, isn't it?
Back to front.
It's up to you. What do you think? What do you think?
So we could switch it out for generating a grid, but I think if we do that, we're just going to be writing a lot of code to manage the transition between those two coordinates. I'm not really sure there's a huge amount of value in it.
Do you want this on the array extensions?
I think the smartest thing we can do.
Extensions go. Okay, yeah.
Instead of using the standard array accessors, we can make a method that just flips the x and y.
And value?
Yeah, that's cool. So I think the smartest. Sorry, I think I scrolled you.
Sorry, I'll just wrap this up.
Cool.
Not even a map anymore.
Of course, refactoring to extension methods. Sucks.
And I totally forgot what I called it. Find value.
And I think we're green here.
Yep. Sorry, you're saying?
I think the simplest thing we can do, because you're right, the coordinates are a bit of a head fuck. So what we should do is we should make a method that flips them, rather than messing around with.
Yeah, it's just not how the brain works, right? Like anyone who ever looks at this code is gonna go,
Yeah, you
huh.
have to read WorldMap X and Y. I mean, maybe the simplest thing is we'll do something like WorldMap, and we'll pass in a constructor parameter of a string array source, and we'll just lift this code we've got over here, this one-liner.
Yeah, and then like control the flipping of it in there. That makes sense. I mean, it feels like that is a thing.
Exactly. So we'll do this.
It's supposed to be a string. Right.
And then we'll say world map equals source. Just do that. And then instead of using raw access, we'll just do a public char value at in x in y. Return world map yx or yx.
Sweet. Make it read only. Cool. Nice.
And
Simple.
whilst it's not exactly beautiful, like it's good enough.
Yeah, but then we can easily just add an index property, an indexer on it or something to make it a bit more air quotes nicer. Do you know what I mean?
Yeah. And then, ironically, we have to change our extent. It ceases to become an extension method. Actually, this is an interesting example, isn't it? Because it shows how we're actually growing a domain.
Yeah.
In that find value is no longer an extension method after we went to all that effort to do it.
Cool. Let's kind of paste it into the world map.
Yeah. Nice and easy. Find value. Cut that.
And it's one of these things, isn't it? Sometimes it's very easy to try and stay too primitive for too long, and it's like it becomes easier if you just map that to what it is in your mind. Like, this is the map.
Yeah.
How do I look at it? How do I talk to it? Yeah.
I kind of like how it all came together then, actually.
Yeah, it's quite nice.
It's quite elegant. Well, elegant for a given. And there's almost, in fact, this whole extensions class. I mean, I won't move that for now, but we could conceptually fold that in. And we'll probably, in fact, we should bring this in now and re-home the tests. So I'm going to pick that up as well. And it's ugly.
Damn, you ugly.
Oh yeah. It's just horrible. But it's okay, it's controlled horrible.
It's good though, so we can drop all the guard claw stuff.
Yeah. Yeah, he says just repathing them. Why is it not? Oh, static. That goes in, and then what we do is map MPA map equals new world map, and that's an empty string.
Yeah, it's starting to feel a lot more right.
And then map equal world map.
That's probably done. Well, actually, no, it's no string.
What's this? Try to come up with equivalent tests. That's that.
That's not equivalent though, is it? Because this was like creating a map based on a null value, but that's not trying to create one, is it? I mean, that is not.
Yeah, it was null like that. So I replaced it with a null. and that is just 1, 2. And we still have one failing build thing. Let's align that. And that's here, WorldMap. And I appreciate that it's in grey code, but point X, point Y.
It's probably create an overload for point.
Absolutely. Okay, so we actually have a world map which is pretty much covered by tests. This one's blowing.
Yeah, this is what I was saying. Like I said before, we were creating the we were doing neighbors based on the array, but now this array has been like internalized. We're basically saying a new
yes. So that's null, right?
Yeah, exactly. And then we can just do that.
Yeah.
And that should, well, it's probably going to fail because we probably don't have the same check. Oh, how do I get up there?
I don't know. Oop.
Oh, sorry.
Sorry, I was scrolling. So let's just go there.
Yeah, so like, so it should be empty, right? So if string dot is null, we're doing white space?
Yeah, just do it. And just negate it.
I was just going to do, yeah. Right, just do a new list. No, what have we got? We've got a string.
Yeah, new string array, 0. Cool.
Oh, thanks. Brain fail.
There we go.
God, that is ugly, isn't it?
It's the worst API. Okay, but we're back into our happy green place.
Awesome. I feel happy now. Thank you.
Right. So what else do you want to? Is there anything you want to refactor around here? Because we just we dragged those pieces around and formed a domain, but
yeah.
Actually, that's okay because we've internalized the horrible.
Yeah, and it's read only. It's not going to be that slow. Like it's not. I don't feel there's anything jumping out at me of like, oh, we've got to fix that.
That's horrible, but I don't care for the moment.
Yeah, like to be fair, that's one of those classic cases of yes, it's horrible, but like it will be consistent.
Yeah, quick and dirty.
Like, I mean, the only thing we might want to do is add a change just to be a bounds check because obviously that's going to throw blah blah blah. Like, yeah, that's there'll be a performance problem there. But like,
exactly. But we'll
like,
I so don't care about that thing.
Yeah.
Okay, so we've got a load of green here. In fact, we could even go if. So this is if star x is less than typing x, then return xs xd. I mean, obviously, this blows up for diagonals at this point, doesn't it?
Yeah. So should we maybe try and tackle that next? Do you think?
Yeah. And that is the the honest to goodness first user story. I will pathfind diagonally, which means we already have the ugly case from up here. And I will just dupe this up here. Boom. And that's here, a diagonal path. Diagonal path. And what we're expecting, let's take that from there, is that. And there is our failure. Huh, interesting. Because it hits there and just returns it.
Yeah.
I mean, I can short circuit that and start x equals start equals dest x. And we can similarly actually do that. I'm going to do it just for simplicity's sake. We'll end up deleting this code later, but that's kind of okay.
Yeah.
It just keeps our greens green for the interim. So that's saying if x is that and start y, it's like the simplest case of pathfinding ever. Dest y, green, and actually it's the other way around. And we should have everything passing except our diagonal. So let's make sure we have the name right. Paths diagonally. So obviously this is failing because we're into our loop. So now we're into our real implementation.
Cool. So right, for every one of our neighbors, we got the tile type, we got the difficulty. I mean, we're not going to do anything with that yet.
I kind of feel like we need to put together like a second map of the difficulties.
Yeah, this is. I was just thinking about this as you were typing. I was like, well, I think maybe we're running into like difficulty because we're constantly trying to map strings to something that isn't a string, right? Like it's kind of.
There's actually
Hmm?
There's actually a concept. There's a data type here.
Yeah, like it's not doesn't feel right anymore, you know.
But it's okay. It's like the string representation is literally our world map, but we need some kind of data structure that represents the what we know about it and the distances. I mean, we could even our world map can know more. There's no reason our world map couldn't know more and keep that information.
Yeah,
Okay, but again, back to the direct task. The way that we know, because some smarter people than us proved it, is that we select for walkable choices, and then we go through the list of tiles and then assign a cost. So we've got to work out what walkable choices are, but we don't care about that because we're not got a test case for that yet. All we're doing is we're assigning a difficulty.
Well, the difficulty is going to be for that one tile, right? And then we need to that doesn't take into account the distance, right?
Exactly. And I think this is an interesting case where the A-star algorithm suggests you use a Manhattan distance, and I think for a 3x3 the distance is going to be the same, isn't it?
Yes.
Which is
so should we just so if we put that in, then in theory, can we tab back to the other thing? I think I've just done the wrong thing. So if we calculate the distance, choose the best tile to move to by comparing the score. So we should only get one result, right? Is that what we're saying?
Well, I think what we're going to get, if we actually look at this 3x3, I think the Manhattan distance for that, so that'll be 1, 2, 3, actually, so that'll be 1 move, 2 moves, 3 moves. That'll be 1 move, 1 moves, 2 moves, 3 moves. I think when we calculate the Manhattan distance between all of these, actually no, that'll be better. It will be better. So what we're doing is this. So you can calculate the distance from tile to the goal using the Manhattan distance formula. So we get all the neighbors and we calculate that for each neighbor and we add the difficulty. So I believe the idea is you add the difficulty to the distance. So I stole this originally from Ruby Quiz, and I have this feeling that I missed the cost here. Yeah, look. So there's the score. There's a bit of a fail in my my kata. Well, we're kind of doing that.
Yeah, so we calculate the score is equal to the cost, which is based on the difficulty, and then
Cost is that.
No, is it? I thought
that's distance.
That's distance. Yeah, this is cost.
Yeah, and cost is the tile type.
Yeah.
So let's change this to difficulty plus distance to goal. Okay, great. So we know this.
So if I sorry, go on.
I was going to say just before we. So we know right here we have destination. So we know the x and y of the destination. So we can do the maths.
Yeah, so I was thinking, with this is not gonna, sorry, I'm thinking out loud, miss, I'm being an idiot.
Sorry,
So yeah, we basically work out the distance from, is it this point to the
yeah,
destination?
from the neighbour to the tile.
So distance. So if we say point, what we call this, Manhattan distance,
Yeah,
was that,
yeah, we'll go with it.
to
Point.
destination.
Yeah.
And then if I just grab this, and then that's going to return I guess.
Yeah.
So this needs to be.
So that is this x, and then dest x.
Whoop,
and then this y and dest y. Cool.
not too far, I think. No.
Okay, before we move on, let me just get this out of the way. We don't need these anymore. Let's shove them in another file. Less scrolling.
Cool. Right. So we now have. I can't believe I'm scrolling this. I always yell at everyone else, say, "Yo, I use Control T." So difficulty,
Plus distance.
and then we basically want if so we want like point winning.
Yes. It feels like we could do this with a little bit of magic link.
Probably.
We'll refactor to that.
Yeah. So if the score is better, so we need the last score.
Yep.
I guess we start at. Ooh.
Actually, we don't even need the last score. All we do is we say if winning equals null or score is less than. I said winning. I didn't mean. I meant lowest.
Yeah, of course, yeah.
Equals like int 32 max value. Score is less than lowest.
The lowest equals score.
Yeah, winning equals null. Score is less than lowest, then winning equals point. Something like that.
And then you need to update the lowest score.
Yeah, yes.
And then we should be able to say, shit, what is this supposed to be doing? I've lost track of where we are. So this is going to give us the best match.
You're finding the cheapest next cell.
Yeah. So then we basically want to say.
Well, then we're kind of back to our outer loop that we don't have at the moment. So there's kind of an outer loop around what current is that I've commented in here.
Yeah.
And it's basically we're saying while current is not the destination. Because we're basically walking to the destination.
Yeah, I'm just thinking, do you want to deal with that? So I feel like we basically got this, like, we need to get back to this damn string.
Yeah, so let's give this this damn.
Like,
let's give some of these concepts some names. I think it might make some of this easier here. So there's a lot of stuff we're doing here. So we're getting the Manhattan distance from a point. There's a score from a point. There's a So I reckon we can fold these two things into a point. So this is the
like get quickest point,
it's literally the
easiest point. Yeah.
Okay. So if I go here,
Need the title type as well.
so that's Manhattan distance destination, and I need the tile type, but I kind of have that, don't I? No, I don't.
Maybe just pass in the title type and then pull this
So it feels.
difficulty into it.
So we're saying, hey, give us the tile type from here. I mean, fine, I'll just pass it in for the time being.
Like we literally never want the difficulty outside of this, right?
Yeah. It's just the difficulty in there. No, you're right. I think what I'm doing is stupid, and I'm going to stop. I don't think this has any value. Okay, so from running this, we will discover what the next point we should be in is, and we want to get back to this string.
Do you know what I'm thinking? I'm thinking this would be so much easier if we took the map and just like so wait, we've got the world map here, right?
Yeah.
And then we did something like
like mark step.
I like step, mark, step. And then, like, we probably want to have some, like, we can't, well...
But we want that outside the loop, you know. So that's all fine. Let's just leave that not imp. If we leave that not imp, so much scrolling.
Oh shit, yeah, of course, yeah, sorry.
We do this here.
Yeah.
So we mark step winning. Great, that's fine. I want it to blow there. I'm going to stick this while loop in. Current does not equal dest. And that's going to kill my computer. It's going to loop forever. So our current does not equal the destination. It's saying that you can't ever do that. Okay, fine. Shut up. My current doesn't equal destination. So we'll go.
Actually, yeah, then we just do current equals winning. So we've marked the step, current equals winning. And then we need to basically
make sure that when we...
I think this is fine, yeah. If we just set current in here, all the rest is based on current.
And we just need to do something like down here. Yeah, sorry, do what you were going to do. You said you were going to set current?
So like what I'm thinking is like, because we use current in here, and it starts at the start, if we update it, it bases the neighbors on all of this. So if we just say current equals winning, so that's going to be move it to our step, and then reevaluate it, like round and round and round, and then that should stop your computer catching fire.
So we have that, and we're basically returning something like return world map, visualize steps. We'll go with that.
Yeah.
Return nothing. So that's obviously bust, but that's fine. So
and then maybe if we, on this one, mark step, we just push on to an array.
Yeah.
Yep, so let's just, wait, this is still the thing, isn't it? Let's get so much scrolling. So let's add a...
Just make a private list.
So steps.
Yeah.
Oh, function key, not control. Then.
Yeah, knew it.
Oh. Gimme. Oh god, whoa! Is there something still cooking on your machine? Because it seems a little unresponsive.
That was my fingers clicking on the keys. It's fine.
Okay, cool. Right, so now we have the steps, and then we want to say steps.add winning. Love the name.
Winning.
Then we basically want to say go through the string.
So before we do any of that, let's just snap through it and see what the crap happens when we actually do this. Because we've,
Technical term.
something crazy is happening here, and that's fine. I'm super okay with something crazy happening in this. But I'm just curious.
Oh, yeah.
Oh.
It's because the dot. No, not a dot. What's the other one? S or D?
S or D are both return 1.
Is it 1? Is that right?
Yeah, well, we'll say it is.
Because this is going to put us in that circular loop, right? But that's another test, I guess.
Yeah. Though apparently it's still breaking.
Actually, no, because we've been calculating the distance, so surely that would work. I don't know.
Let's do this again. So don't care about any of these. Okay. Well, actually, let's let it run and let's break into the first covering test at this line. So tile type is a dot. Difficulty, we'll let it go round. Tile type is a dot. Dot. Tile type is a dot. You're a dot. You're a dot. You're an S. Hey S. That's fine. You're a dot. You're a dot. You're a dot. You're still a dot. Everything's a dot. You're an S.
Should we see yes again?
Yeah, I mean everything kind of seems okay here.
I feel like we shouldn't be saying.
I feel like what's happened is wow, nice hot spots here.
Yeah, like we're going around too much.
And Visual Studio just crashed. Awesome.
Really? Sweet.
Yeah. I think that is the definition of a Stack Overflow.
Yeah, wow. You're welcome.
Wow.
I've just warmed the room up. It's fine.
It's good. It was getting cold in here. But, let's do that again. Let's get Visual Studio back.
I'm trying to think where we could have gone wrong. So the current thing. Might want to disable enCrunch if it's not disabled already.
It's disabled itself.
So you sort your fail out. Okay, so what's this moaning about here?
Should we just step through this thing? Because we know this is the broken one.
Okay, yeah.
I mean, we
I think I spotted it. Are we hitting we're not traversing the new lines? Or are we? I don't think we are.
I think we just blatantly got an infinite loop.
Yeah, like we're not going on to the next line, we're just going...
Okay, right, so for each point in neighbours, let me walk down to here. We found a winning point.
Yeah, we need to break out. Like once we go through all of the neighbours, we need to get the hell out. Because we're trying to read the whole... Well...
That's just for one cell, though.
Yeah, but what I mean is we need to, once we found the winning one from the neighbours, we then need to reevaluate this whole thing based on current. I'm not sure if we're doing that. That's what I intended to do the first time, but I think I missed something.
Okay, so we're starting here with current equals the start.
We are doing that. Okay.
Yeah, like it seems okay, but I reckon this is just never hitting here. Let's see if NUnit's test runner doesn't collapse Visual Studio on the way. If we just run this through, I reckon we'll never hit my final breakpoint. I hear my CPU are grinding. And this is warning me that nothing is ever... Yeah, we're just blatantly never hitting this, are we? Current never equals destination. So we're never getting there.
But why?
Okay. So let's come all the way back out. So this is a very, very simple test case if we actually look at what our world looks like. It's a 3 by 3, so we've got to be missing something fundamental. So we're getting the neighbours of current. There are 3 neighbours because it's top left. And then we go through each of the neighbours. So there's 1, 2.
So it's only found the one winning one.
3. So great. So we have a winning one. So the next step should be 0, 1, which is exactly what I'd expect it to be. We're then setting the current to the winning one. We're saying great. Now get me the neighbours. And we have 5 neighbours now because we're in the middle of the board, I think.
Yep.
Well, actually, where are we? We're in 0, 1. So we've stepped down 1. We stepped down 1.
Is that right?
That's what I was saying about how I thought the Manhattan distance would be the same for a couple of different paths here. So whilst it might not be right, it's technically correct.
Yeah, sure.
So now it needs to get closer. So I believe in the original Dijkstra, I can't pronounce his name for the life of me, computer science fail. The original algorithm, they keep a list of visited nodes and don't revisit nodes they've seen before.
Yeah.
And I think what's happening here is we're literally running around in circles. So I think here what we'll find is, okay, so let's just take it all the way down to here. So our winning step here is now going to 0, 0. So we've gone
back.
I'm not sure why we would have gone backwards. It doesn't make that much sense to go backwards. So okay, fine. Let's just try extend it to that. So var visited equals new list point.
And then we're just going to exclude.
So we're gonna add everything we've actually visited. So marks. In fact, we already have the path in here, but let's just go with it. Visited, add winning. So here we get all the neighbours. Remove.
We'll just do WorldMap neighbours dot accept.
Oh, accept visited. Yep. Yeah, you're absolutely right. Sorry. So doing that, neighbours, except the ones we've visited. So let's step through that again. And let's put a breakpoint on here. I think that's the useful piece to look at. So we come down here. So the winning point is 0, 1, so we've come down a step. Neighbours. And we
should not have 0, 0.
So obvious rookie mistake. Obvious rookie mistake. We didn't put the start in the thing that we don't want to go back to. Great. So we go down to 0, 1. And then we shouldn't go back.
We should totally override or set up a debugger display.
Yeah.
Like, so annoying having to expand all those nodes.
So the winning thing here is 1, 0. So it's gone down to 0, 1. Like, it definitely doesn't seem to be doing the right thing here.
So it went to 0.
Now it's gone to 1, 0. So it's gone diagonally, but not the way we expected it to. It's kind of walking around in circles. It's going to get there eventually, but we managed to build an algorithm for the least sensible pathfinding.
No, this is for the good of the human race. Is to get your pedometer count up.
No, it's 1, 1.
So you hit your 20,000 steps a day or whatever it's supposed to be.
I feel like it's never reaching the destination. Like it's not seeing it as a candidate. So current. So the destination, we're trying to get to 2, 2. And the current is 0, 2. So the neighbours 1, 2. It's like it's literally avoiding.
I feel like I've screwed up the Manhattan distance thing. Like that's the only logical thing I can think of is like, yeah, it's because it seems like it's just going like.
Oh no, we've not taken into account the previous distance travelled. So the 1 square, so the distance you have to add. Let me jump back to the original notes.
Oh yeah, there was
Cost
choosing.
so far plus the cost to move to the tile being considered, and that's.
Isn't that what you copied and pasted from the Ruby thing? No, that we got all that, but like.
So we're not taking into account the cost so far at all. So
No.
everything kind of looks like a good.
Of course, yeah. So we basically want to say we want to track the current score, like the running sum.
Yeah.
Um,
So it's another thing down here at the bottom, isn't it?
yeah.
The cost so far.
You writing, or do you want me to do it?
Go on, you go for it. I'm thinking.
Okay, cool. So if I just put another thing up here, oops.
I think you need to be outside that scope.
Yeah, thanks. That's the function key. So we've got our running score, and then blah, blah, blah. Then when we choose a winner, we then add that to the score.
Yeah.
And the score needs to be based on that plus running score.
No, we need to do this outside of this evaluation, I think. Oh yeah, sorry, you said exactly the right thing.
Yeah, I was like, I'm
being thick.
No, I'm really down myself because my head is all over the place. And yeah, so then if the score is the lowest one, no, is that right? Wait.
I mean, it seems right.
Like, let's just run it and see what happens.
I'm gonna go.
Yeah, you're gonna run it.
Let's give it a go. So debug. So the first winning step against.
This is hilarious. I totally feel like I'm.
It's basically walked 1 across.
That's not expected though, right? But fine.
So walk 1 across, and then we got some more neighbours. And the running score is -12. Interesting.
No. Running score.
Yeah.
Huh. How like
Sorry?
how the hell have we got a minus number?
Because of this.
Okay. Is this supposed to be the other way around?
Should we give it a go? Should we just flip them?
Yeah, I just hate this. I hate this. And then when you're like bumbling through something, like you just feel like.
I mean, I don't think this is meant to be necessarily trivial, so. So the score at this point, and that's totally out of scope, is 0, 1, so it's gone down 1, which is what I would expect. Then we've got more neighbours. And it goes through the neighbours, and it works out difficulties and scores. So we've got a winning.
Like whenever we update the winning, we add the running score. We probably don't want to be adding it like this. So every time we pick a new winner, it's going to add, right?
Oh yeah, of course. It should be outside the scope.
Yeah, it's a fail on my part, I think. Well, it was. So like this should be we actually want to say so it is outside the scope. We only want to add the score
Once we
when we mark the step, right?
correct.
Which we're not gonna have access to.
It just means we have to pull this up here. Like, again, let's just make sure we do that. So score is that. And when we finish it...
So we can get rid of the...
Oh, it's just its lowest, isn't it? We've already got it as lowest.
Yeah, but that... Oh yeah, we have.
We already have it. It's just lowest plus equals lowest. That is what it is. So it now went to 1-1. Hey.
Yeah, that's looking better.
That's where I thought it'd go. Then we do that. Then we go there. Then it goes to 2-2.
Which should be the destination. Then we stop. Then we blow up because we've not done our map.
Okay.
Oh god, that was hard work. My brain is... I feel like I'm just about to get out some graph paper and be like, okay, where the hell am I?
So take two people that don't do loads of maths and make them do things that even resemble maths. And this is what
Yeah, this is hilarious.
Okay, but we can do programming stuff. We can do this.
Yes.
We can do this. So all we're doing is we're taking the original string. So this will be nasty. Copy of original string.
I think if we just get it into an array, clone the array, then just do a for each over the steps.
Output equals.
And then just replace the value with the x, right?
Yeah. New. I know this is nasty again, but we'll go for it. Autocomplete is not my friend today. There we go. So we've got a copy of it as a list of strings. And then for each var point in traveled
steps.
Yeah. Output. Output. Y.
Lol.
Point Y. Point X equals. Hey, will it not let me do that? The index of this string has no setter. Okay, fine. So line point.
Should I do? Oh yeah, of course.
Insert.
Is there like a replace that with something?
Feels like there should be, but there is not. Okay, well we won't use a list of strings.
Can't I just put that in a char array, the line?
I'll tell you what.
Then do join. God, dude, this feels like so much work.
Okay.
Okay, so what did you just undo? That was the array, right?
Yeah.
Next. Okay, so get the line. Cool. I'm on brain. We can do this. Line. So this is point.
So I was trying to set it like that as well.
Yeah, this is going to say no, right? That's a char. So let's just go x. Oh, is it lowercase?
It's lowercase.
And they said it didn't like that.
Well, that'll work, but isn't that line a copy? Hasn't it just made?
Yeah, that's gonna be a copy. But then then what I'm thinking is output point dot y.
Point dot u.
make it big. That's going to be. What is this?
This is we're being special.
Ah, yeah, I feel like I'm being quite special.
Okay, so how about this?
Oh, it should do join. Should have read. That's why. Oh god, I can't type now. Ah, brain imploding. Ah.
I have no idea what you're doing.
Huh?
I have no idea what you're doing.
Just doing this.
You're just doing that.
Oh my god. Apple keyboard. Stop clicking.
Let me type it for you. Right. There you go.
No, it's not. Separate it first. That's what I was trying to write.
Could that even possibly work?
I don't want to find out, dude.
Yeah, okay.
Then, oh god, this is so hacky.
I have no idea what this code even does.
Output.
So that's not going to work.
You sure?
Okay.
I have no idea. Can we put it in the console?
Let's enable mcrunch.
Fucking debugger. Like, it's horrible. Let's see what I screwed up. Can't quite see that. Hang on.
I know that's actually, it did work.
It's really capital X, and we don't want to replace S and D.
We don't want to replace S and D. That's all it is.
Ha! You have little faith.
Yeah, I still can't read what the crap you wrote, but we'll visualize.
I don't think it's pretty. I really don't.
Okay, just skip the last step.
It's supposed to be capital X, right?
No, it was lowercase x.
Oh, it was right. It's just the S and D. Right?
Just skip the last step.
You skip the last step. What do you mean?
As in everything but the last step, because the last step is the step into the destination.
Oh, okay. So is there an easy way of doing that? There's no splice, is there, or anything like that? Slice even.
I feel like there should be a clever link way to say everything but the last one. You can do it in a really cheap, hacky way.
What's this one? Index. Yeah. So there's no overload. Like
do you want me to do it in the cheap way?
Yeah, go on. Show me. There's gonna be a super cheap awesome way.
You're gonna hate this. Steps, reverse, skip.
Oh, dude. Oh my word.
Something like that. I don't know. It's not allowing.
Like I was happy with the horrible one that I was doing. Like I was gonna. Okay, sorry. Get range, naught.
Length -1.
Yeah, like I still feel like that should be easier.
Stop length.
No.
Dot
Can't type.
Step
Yep.
stop.
Oh no. Oh god, come on, Rob.
There it is.
You can do it. And they go to that. I think it was throwing me out because I had the full stop up here.
Look at that. Look at that. Look at that sweet.
It's beautiful.
Sweet green code of doom. Sweet code of doom.
I'm gonna look at the Q&A and see if someone's bitching us out about not using string builder.
It's been fine.
Oh, cool.
Apparently we've not got it also obviously terribly wrong that people notice.
Even that, they're still laughing.
Try something clever.
Oh, fire in the hole. Yeah, I think that should be fine now, actually. Is it good? Does it work?
Yes. Yes, I think it actually...
I think we're actually pretty close now. Like, it's ugly as hell, but I think we're getting it. Yeah.
I think this might actually be a correct implementation.
Okay, let's do this. Let's put some trees in there or something.
Okay, should we go for so one of the things
all in? Right, let's do this.
Unfortunately, we can't go all in at this point.
What?
The reason we can't go all in.
Oh, we haven't got the blockade.
Yeah, we've not got the blockade.
It's ADE, by the way. I was gonna say later on, but it's ADE.
Oh yeah.
This is aids blockages.
Yeah, I'm helping the blocks. It's
yeah.
good.
Should we do that?
we've got 15 minutes left. We can either do that now, or we can do another session in a couple of days or next week where we polish off the implementation with a couple of these extra pieces.
I was gonna say let's throw in some trees because we do handle trees. Like we should be able to, yeah, like or at least we should handle trees.
Let's get a test of that. Yeah, we've got a V with a 5. So
this code is hilarious.
And in fact, the test for that I already have. I already have it in here. It's this one. Yeah.
Didn't you have another one though? It was like there was like a tree. I guess you'll call it a tree line. I just don't remember where I saw it. It might have been the Ruby one. There's like the tree was like a V or something.
Yeah, this is the simplest case.
No, sorry, like a V shape on the map.
Yeah, there. That letter V is the tree.
No, I mean it was like used up multiple rows.
Oh yeah, we've done that. But let's just see if we can actually pathfind around a single V, because obviously the fastest line between the S and the D there is
actually around it. Yeah.
So it should path around. So let's take this and dupe it, and then go X, and hopefully. Oh, I always want you to work, but you never work how I'd like.
Wow.
And oh, that's just worse. Alt, come on, multi-select. There we go. So what I would expect here is...
It should be like X's down the middle.
I think it should do that.
Yeah.
Okay, so... what's the name we've given them? Path. Path is around expensive route.
The method's totally not called path as well.
No. Walk. It's called walk.
It's like, for the record, I do TDD, I swear to God. Yeah, looking at this, you might not think it, but...
Wow. Well, I did not...
We got 2 dots in there. What's that about? No, that's right.
No, it's not right. It went everywhere.
Yeah, it took the scenic.
I think the scenic route is one way to put it. It visited every single... Oh no, something is wrong here. I know, XXX. God. What on earth did it do?
It's got to be time to do that score calculation.
See, if you hadn't have said let's go for broke, everybody that was watching this would have thought we'd have got it right.
Yeah, but now we go down in a blaze of, I don't know, glory or something.
A blaze of failure.
That's it.
Okay, let's. I'm curious. Let's see how this went. Break into first, failing, covering, test. Let's see which way it went. Okay, so this is all fine. So the destination is 02. Yeah, that makes sense. We get all the neighbours, and then we go through. And then
this thing is all screwed up X-Y coordinates again, is it?
So this is good. The first thing it finds is the V, is the tree. So it's saying, hey, get me 0, 1. And my difficulty is 5, and my distance is 1. So my difficulty plus my distance is 6.
I got a question. So I'm confused that it found the V first, because that was below it, and it should be top left or bottom right. I'm thinking the issue we got here is our X and Y coordinates again. Like, these always bite us. Like, every time. Like, every time. We have to get our grids. No more grids. Like, do you know what I mean? Because I thought that our neighbours should return top left or bottom right.
But it's okay. We can take a look at this. So, okay, cool. Let's just step over that. So for each possible point P, so the first P I'm looking for is -1, 1, which doesn't exist. Right?
Cool.
So that's not found. The next one, -1, 1, again, doesn't exist. And this should obviously be a bounds check, but fine. 1, 1. So the first neighbour is 1, 1, and it finds it. And 1, 1 is just a random space in our test.
Hey, but 1, 1, 1.
It's just because of the order we've declared them in here.
There should be 0, 1,
Okay, well
shouldn't it?
let's go all the way back to the top.
I feel like it's the y coordinates that are screwing us up.
Look, well, these are the points we're looking at: -1, 1, 0, 1, 1, 1, which exactly correlates to -1, 1, 0, 1.
Yeah, but what I mean is like,
And 1,
so
1.
our start one is top left.
I think you're being confused by
I'm
the
sorry.
order. I think you're being confused by the order that we've put these points in here, because these points are basically ordered arbitrarily.
But they're not top left, top right. Around our point of starting, right?
Are they top left and bottom right? Well, that one doesn't exist, so for this case it doesn't exist. This one is now... No, they're not really top left to bottom right. I think our coordinates are fine, you know. The code's just scummy that gets them. So the list of neighbours that we were looking for here are valid. So the neighbours of 0, 0 are 0, 1, 1, 1, and 1, 0. That's fine.
Okay.
So the first is a score of 6 because it's an expensive, it's traversing through some trees. But it is the winning score for the time being, and then we get the next one.
Isn't that maybe lower?
Yeah, so that's now lower. So now it decides that actually instead we're going to go through 1, 1, which is exactly where I want it to go. And then here, yeah, fine. So it's going to go through 1, 1. And that's perfect. So what I don't understand is why it doesn't just step from 1, 1 here.
So what is current right now?
So current, we're now in 1, 1, so we're in the middle of the grid. So actually, the shortest path through here is just a step to the destination.
So which is going to be -1, 1.
Oh, there's probably just a cheat here, isn't there?
What I'm saying is the winning neighbour should be -1, 1, right?
Well, the winning neighbour now should be the destination.
Yeah.
And there's almost there's a hack here. A super like I don't think it'll stop. I think we've still got a bug here, but there is a hack where we can say if the tile type is D and it is a neighbour, just step to it. That will always work.
Fair. Yeah. There's no point calculating difficulty if you already know.
If you know the path, right? So the difficulty here, distance of 1, running score -2, fine. So the difficulty of this one is 2. That's the next logical step. But then the next point comes through. There's a tile type of a dot, and the score is 1, so it walks away.
So we basically want to say
Let me try this.
the score for D should be 0.
Yeah, exactly that, right?
And S. Well,
No, just D.
yeah, I don't want to go backwards.
Or we just do that.
In dot, mid-menu.
Yeah, like, you go this way the whole time. I still suspect there's a bug in our pathfinding, but we did succeed.
No, I'm not so sure because like I think if you never actually say go to the destination, it's always just going to go round and round and round, I guess.
Of course, because if it's in an open field and
yeah,
all paths it can take are equal, it's
exactly.
It's just going to go wherever the hell it wants.
I mean, the easiest thing to test it is maybe just expand that, like
yeah,
expand.
Let's just do a Mickey Mouse test.
Yeah.
Blah.
Ha ha.
So, okay, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3.
Do you maybe want to expand the trees?
Yeah. So we want to do. Let's hit insert. B.
That's quite.
Never hit insert. And we're expecting it to go.
You might want to take one of those V's off because I think it might be cheaper to go for the trees now.
Yeah, you're probably right. So I'll tell you what. Let me just take one of those trees away there, and we're now expecting insert x x x x x. I'll be amazed if that works.
1, 2, 3, 4. Ooh.
That's
Yeah.
fine. Well, let's
Maybe shift the destination to be under the second line X. Do you know what I mean?
let's just try this. Console right line path walked. NUnit will at least render this pretty. I said render it pretty. God, fine for each line in path walked. You're gonna make me use this crappy API again.
Oh, you love it.
Environment new line. String split options, nothing at all. Oh my god, I hate you, I hate you.
It's not a string got lines.
And obviously, and because the test is failing there, it's never going to run it. Yeah, look. So here, can you see that? It must be too small. It goes the right way here, and
then it gets confused.
Then it gets confused and runs away. So it's going the right direction. It finds its way. So what's failing here, I think, is that all the paths around it look equally expensive. So it's walking until it finds the destination.
Yeah, I imagine it's probably going like outwards and then coming back in.
Yeah. So I think we have a bug in the part of the algorithm that basically says add the total cost up to this point. I think there's something about this we're not quite understanding, which it makes sense because it's the first time I've read the instructions to this algorithm before.
Yeah, likewise.
So I think we should fold it here. We know where the bug is. We've basically almost implemented it. We'll stick the code on GitHub. But I suppose what we've proved is with a little bit of elbow grease, you could probably do this in 2.5 hours.
Yeah.
I'm pretty confident we could find the bug in our calculating the running score in about another half hour if we really put our minds to it.
It's kind of funny because my brain has been not with this at all, but like we've just been bumbling our way through it with tests and like.
We still got there.
Yeah, it's like there's one minor bug, then it's ugly, but it'll work.
So if anyone who's watching is wondering why all the video games you play, the characters walk into walls, exactly this.
We wrote it.
It's exactly. Awesome. So we're going to leave it there. I'll push the code up to GitHub or something, and anyone watching can have a play with it. I hope this was fun. I can see people online. Same time next week.
Thanks a lot. It's been fun.
Yeah. Take care, guys. Bye bye.